continue. Okay. So to pass arrays, the topic is passing arrays as arguments to methods. So here we first declare array. So array is people with 4 different names. You see, we have a method. That method is self-defined. We define a method which is show array. So you see that for this, when we define the method, so we have one parameter, okay, which is a string array, okay, which is a string array. And inside the method, we would like to what? We would like to use for each, right? Last time, so we learned how to use for each loop to enumerate all the elements in an array. Okay, how we use for each loop. So we use string. Str is a string variable in string array. Basically, we would like to display each element in a message box. Okay, in a message box. So that is a self-defined method, and in this method, we use an array as a parameter. When we call the method, we will pass a predefined array as an argument. Okay, that is the idea. So the array elements can also be passed individually. So in this case, right, because you see show people. So in this case, we do people index because people is a sequence of string variables. It is a string array. So people index will be one element in the array, right? It will be one element in the array. So when we do show people index, so show people will be a method with a parameter with a string parameter. So here is one example. Write a method which has a int array as the input argument and return the average of all elements in the array. So in this case, we have a core average method. We have a parameter int num array. So in the method, we have first declare average equals a decimal variable 0.00m, and we try to enumerate all the numbers, and you can see average plus equals num array index. So in this, we would like to sum up all the elements in the array, right? In the array, when we have the sum of all the numbers in the array, the next step is to use the sum divided by the number, right? The length property will give us how many elements are in the array, right? How many elements are in the array? We use the sum divided by num array dot length property. That will give us what? Give us the average. Okay, average. Then we use return average. Don't forget, because for this method, the type is decimal. It is not a void. It means you have to have a returning value. If you don't have that statement, return average. Okay. If you don't have that, then C# will give you an error. So this is an error. You have to have a returning value for a non-avoid, right, type of method. Okay, non-avoid type of method. So then we move on to the next part. Okay, next 2 sections will be, I feel, will be the most difficult part. Okay, in this whole semester. Why? Because you see, in the previous, I think this week 11, okay, in the previous 10 weeks, okay, all the materials, all the lectures we covered are for what? Are for basic concepts. Okay, for example, we learn what is a variable, what is if else, what is a loop, right? What is array? Those are basic concepts. But in these 2 subsections, we are going to deal with what? Algorithms. Okay, this is the first time that we are going to deal with algorithms. Okay, in the whole semester, maybe this is the only time we deal with that. But as you move on in computer programming, okay, for example, if you in the future, if you just learn, for example, senior undergrad level courses in data analytics, So algorithms are less important. Why? Because in those courses, you will focus on two things. The first thing is what kind of algorithms are there, and intuitively, so how each algorithm works. This is the first thing. Okay, you do not need to understand the technical details of each individual algorithm. Why? Because this is not 20 years ago. In 20 years ago, no matter what kind of algorithm you need to use, you have to build it by yourself. Because 20 years ago, internet was bad. Okay, for example, I still remember. So when I was on the grad 20 years ago, okay, 20 years ago, so we had assignment, a lot of coding assignment. Okay, so we need to use some methods. For example, we need to sum up two matrices, multiply two matrices. So in order to do this, so each of us has to build the multiplication sum algorithm by ourselves. We need to build it in scratch, okay, scratch. So it means we cannot find any code. So on the internet, we have to build everything by ourselves. It's good practice, but it is difficult. And to be honest, it is not efficient. Why? Because you see, multiplying two matrices is the standard, right? If one guy or one programmer has built it in, for example, C#, right? So other programmers can use it directly. You don't need to write same code again, and again, right? You can use it. So in nowadays, almost all classic or useful algorithms are on the internet. Okay, you can either, for example, if you in the future, if you try to learn how to do data analytics in Python or R, because these two languages are the most popular languages in data analytics industry. Okay, if when you go to data analytics and you want to be a data scientist, so you will use one of them. Okay, you will not use others because these two are the most popular. Okay. So when we use those two languages, you see, oh, I want to program Python. I need to what? I have to build a lot of algorithms, right? But the problem is, if you need to build all the algorithms by yourself, so it's very time consuming. Very class, for example, this algorithm was designed 10 years ago. It means it is mature. It has been used everywhere. So a lot of people have programmed similar code somewhere, right? So if you need to do it again, right, it is first redundant. Secondly, this is not your focus because your focus is to use this algorithm to analyze data, right? So in this case, so the idea is, can I find some existing code somewhere and which I can use to analyze my data set, right? My data set. So the reality is there are so many existing code on the internet. So for example, building Python, building are almost all classic algorithms are already built in packages. You can just download the package, install the package in either Python or R, then use it directly. Okay, what you need to learn is how to use it. For example, when the coder, right, when the programmer builds the package, so how many parameters are there? When I have my data set, how I pass arguments to the algorithm and use it. That's your focus. Okay, it means we or you as a learner in computer programming, you do not need to program those old classic algorithms by yourself. Okay, you can just find it and use it. But when you move on in the future, okay, but there are also more advanced people in data analytics. You see, a lot of people, some people who got a PhD in machine learning, data mining, computer science, right? So they are working as senior engineer or managers in like Google, Facebook, Apple, okay? So these guys, you may think about why I can analyze data with just undergrad or maybe a master degree, that's enough. Why I need a PhD? Because these guys can write original algorithms by themselves, okay, by themselves. If you would like to promote yourself to those positions, you need to learn those algorithms, okay? With all the technical details, okay? With all the technical details. So that's why, so in data analytics or computer science, so when you want to go deep in this direction, so you have to take a course, which is a data structure. In data structure, you will see that starting from lecture 1 until the end, you will learn all kinds of useful algorithms. Why you need that? Because those data structures can help you to build efficient algorithms, because you do not want your packages or your algorithms to be slow. You need to be efficient, right? For example, sometimes when you run an algorithm, you feel you have to wait for hours to get the results, okay? So which may not be affordable in practice, because can you imagine? You need to tell your boss, so I have to run the algorithm for 1 day until I get the results. So your boss, most of the time, boss cannot afford it, okay? So in this case, you need to build efficient algorithms. Or, so I'm a professional programmer, for example, I would like to build a new algorithm and I would like to upload my code on internet, because I'm happy if other people use my code, right? So in this case, your code has to be first easy to use, no bugs, and efficient, right? So in these cases, you have to learn those algorithms, okay? I explain these things because I want you to understand. So those kind of different levels. For us, we don't need to understand all the algorithms, but when you move on, when you go deeper and deeper in this area, so you will see that sometimes you have to learn technical details of some algorithms, okay? That is you promote yourself to higher and higher level in data analytics or in data analytics. So to be honest, in current industry, okay, so except those big companies like Google, Facebook, big companies, a lot of companies, they are short of professional data scientists, okay? They need a lot of experienced, advanced data scientists. It means if you try to spend more and more effort in this direction, so you will have much better opportunity to develop yourself in this area, okay? Because this still are of undeveloped area. So that is why you can see that in our department, so we have a huge master program. So business analytics and information system, okay? So each year we have a lot of master students who are attracted by business analytics, actually, okay? So for your undergrad students, so we try to encourage you guys to take more and more courses in this direction. So this course is a start, okay? But I encourage you to learn more and more. You will see things become more and more difficult. But that is how you develop yourself, okay? How you develop yourself. So let's see this chapter, which is some useful array algorithms. The first algorithm is very simple. So it is the sequential search. It is an algorithm so which uses a loop to sequentially step through an array, starting with the first element. For example, right, let's assume. So we have 40 students in this course. And I have an array of string array with length 40. And with each element, I put your name, one student name in the element. So which means I have a sequence of string variables array with all the names of the students, right? So but one day I would like to search one name. I would like to see, for example, I would like to check if his grading is correct, okay? Would like to search. So how can we realize it? Because you can see that you have used them for multiple times, right? For example, in Word, right? For example, if I type a name Adams Smith, right? You have used because, for example, if it is a name in Word, I use Control F, right? I want to search Where is Adams? Smith, right? You can see that word can give is here. Okay, we have used this function for multiple times. Now we want to learn a very, very basic algorithm. How we can get it? How we can get it? Okay. So the idea is in an array. Let's assume we have 5 elements. So we need to find one among the 5, right? So the idea is, so first we have to declare a bool variable found equals false. Then we declare index equal to 0. Why? Because remember, the first element in an array has index number 0, not index number 1. Okay, not index number 1. So position equals what? -1. Okay, -1. So you will see why we need those kind of things. Okay. So then we have a while loop. We have a while loop. So in the while loop, we have 2 conditions. Okay. The first condition is what? Not found. What is not found? Not found will be true when found is false, right? It means in the beginning, when we initialize found equal to false, this not found condition will be true. Okay. So we have and with another condition, which is index is less than s array dot length. What is that? It is if index we have scanned to the last element in the array, index equals length property -1. Because if you have 5 elements, length property equals 5. But the index of the last element equals 4, right? When we have reached to the last element and we have scanned it, right? We have to stop because we have enumerated all the elements in the array. If we keep scanning, then we go to nowhere. C# will give us an error. Okay, will give us an error. So this is 2 conditions. First condition, not found means we have not found the targeting element. The second one means index is less than s array dot length. It means we have scanned all the elements in the array. If one of them is false, right? Either we found it, we're done, or we have scanned all the elements, we're done, right? No more need to scan. We have finished all the elements. If one of them is false, okay, or let's see, if one of the condition is true, either we found it or we finish the scanning of all the elements. If one of them is true, right, we're done. There's no need for further scanning. Okay, no for further scanning. So in this case, we have so if S array index equal to value, it means if we have found the targeting elements, right, then found is true. It means we tell the C# we have found it. Okay. At the same time, position equal to index. So we first find it, then we would like to record where is it. Okay, find the value, then tell the user where is it. Because index number can tell you if index number equals 1, so the user will know that it is the second element, right? If index number equals 4, the user can find, oh, it is the 5th element, right? 5th element. So in this case, so we can find it and update the position. Now you see why we need a position equal to -1, because there is no -1 index, right? If when we finish the scanning, position is still -1. It is not changed. Okay, it is still -1. It means we have not found it. Okay, we have not found it. So the targeting element is not in the array. Okay, the search is not successful. So after this if structure, we have index ++. It means we would like to increase index, right? If we don't have that, the while loop will be dead. Okay, the C# will stay inside the while loop forever. Okay, you see, for this simple algorithm, right? So the intuition is simple. We start from the first element, keep scanning until we reach to the end. If we cannot find the element, if we find element, In the middle, somewhere in the middle, we label the target, the index of that element. Then we leave the while, right? While loop. Okay, the while loop. So that is the logic of the array algorithm. Okay, it is very simple, but you see. So this is the first, right? For example, in your data set, right? For a very simple analysis, you would like to see, for example, I would like to see, I have a record for some customers. So I would like to see how many transactions are on November 1st. Then I will go to date, right? I search all that attributes to see that if the date equals November 1st, 2020, if it equals, I count it. If it equals, I count it, and I record the index number, right? I tell the user, for example, there are 10 customers, right, which have transactions on November 1st. And the record number of those 10 customers are somewhere, right? So this is how we use array algorithms, okay? The first algorithm, sequential search algorithms, okay? For this algorithm, the intuition is very simple, okay? I have explained how it works, okay? It means, so you need to understand how it works, okay? Understand how it works, because so in the future, when you learn more advanced algorithms, so this is the very baby first step, okay, for you to learn advanced algorithms, okay, advanced algorithms. So this is one example. Use the sequential search method to search the string array names array to find the position index of the name Alice, okay? So basically you can do the same thing, right? You copy the code with some small revision, okay? First, bool found equals false. Similar, same thing, int index equal to 0, int position equal to -1. So for the while loop condition, not found, either we find it, so and condition will be index, right? Index is less than name array.length. If we have scanned all the elements, okay? All these things are same, but we have some small change here. So here we have S array index equal to value, right? But now we have a specific value, which is Alice. Okay, you do names array index equal to Alice. If so, we find it, found equals true, we got the position of that element, right? Otherwise, we just increase the index. Okay. So this is a very simple example. Okay, very simple example. So which is just have a very small revision if you compare to the example given in the slide. Okay, it means in the exam, if I ask you to write some similar array algorithm, so and first you are prepared, you know that this is the targeting algorithm. Secondly, you have prepared for the algorithm. You know what happens. Okay, what happens, and when I will give you similar question in the exam, you can write it in very quickly. Not I need 5 minutes or 10 minutes to locate the slide. Then I need another 5-10 minutes to read the slide, understand it. I need another 5 minutes to write the code. Then you can see that 20 minutes gone, right? You have no time to finish all the problems. Okay, you need to get prepared. Okay, that is my comment. Okay, that is my comment. So we continue with algorithms. Okay, another one is copy an array, create a second array, and copy the individual elements of the source array to the target array. This is also straightforward. So we just want to copy the content of one array to another one. So in this case, right, we use a for loop. So the number of iterations will be the length of the array. So inside the for loop, basically, we would like to set the value of the second array equal to the first array. So that's it. So comparing arrays, compare each element of the array. So it is, so first we compare the length. Okay, why we need to do that? It is because if there are two arrays, right? If their lengths are different, they are different. Even though, for example, the first array is ABC, the second array is ABCD, right? The first three elements are the same, but for the second array, it has one additional element, number D, letter D, right? They're different, okay? We can compare the length. If the lengths are not the same, they are different, okay? So similarly, we can compare each individual element, okay? So it is also sequential sort. For example, the first element is ABCD. The second element is ABDE, right? So we start to compare the first element, A versus A. It's the same. So we move on to the second element, B versus B. It's still okay, right? We move on to a third element. The third element in the first array is C. However, the first element in the second array will be D, right? C does not equal to D. So one C# scans for three elements. C# can reach to the conclusion these two arrays are different, okay? So you can either first see if the lengths are the same. Then if it is the same, right, you can compare each individual element. Okay, each individual element. So the next one is, so how we find the total value of an array. So basically, we can use loop with an accumulator variable. Okay, loop. It is, we have a for loop. So we have index equal to 0. Index is less than the length property. Index plus plus. So total plus equals units index. Okay, but you need to initialize total to be 0. Remember last time? So if we sum up all the elements, so before the iteration, right, we initialize sum equal to 0. Okay, same thing here. Total needs to be initialized as 0. Then you can sum up all the elements in the array units. Okay, in the array units. Okay. If you need average, you do total divided by units dot length after you sum up all the elements. Okay, after you sum up all the elements. So here is one example. Assume that we have defined two decimal arrays, scores array and curved score array, with the same length. Add 5 to each element in scores array and assign the results to curved score array. For example, the first element of curved score array should be 5 plus the first element of score array. Basically, it is a small revision of what? Of the copying algorithm, right? Copying is a direct copy, but it is, so we need score array index plus 5. That's it, okay? You see, for these problems, for most coding question in the exam, it will like this. So it is not tricky. So I'm testing you if you are prepared, okay? If you are prepared, you should finish all the questions efficiently, maybe the last one. Usually I will, for the last question or last two questions, I will combine two simple examples, okay? Each example is still in the slide, but I combine two. I try to say if you really understand, okay, understand the algorithms or the concept or the examples we have learned in the slides, okay, in the slides. So so here is another example. Assume that we have defined two int arrays, scores array and checked score array, with the same length. Write statements to find the number of unequal elements in these two elements, right? You see that in this case, I'm trying to give you an idea how you can revise those basic algorithms to do something. Okay, in this case, so I would like to count the number of non-equal elements in these two different arrays, right? So first, I declare a int variable counts equal to 0. Then I have a for loop to enumerate all the elements in the array, in the two arrays, right? So my if condition means if the score array element does not equal to checked score array elements, then we have counts plus equal to 1. It means if the the second element or first element of score array does not equal to checked score array of first element, then we increase the counts by 1. Okay, so if they're the same, so this if structure will be skipped. Okay, will be skipped. So with this kind of code, basically, we can count how many elements are different in these two different arrays. Okay, two different arrays. You see, they are not direct copy of these basic algorithms, but so they are small revisions of these basic algorithms. Okay, small revisions of these basic algorithms. So now we move on to our next algorithm, which is find the highest value in an array. Okay, find the highest value in an array. Okay. So which is, if you use Excel, you will know that Excel has a function which is max, right? If you have a lot of numbers, you put max, then you put all the numbers in the pair of parentheses, so it will give us the maximum number, right? So now we are going to learn the algorithm in C#, how we can find the maximum number in an array. For example, let's you have collect sales number in your company. Okay, so you would like to see, so which month will give us the highest sale in the last year? So one way is to check, read the numbers by yourself, right? But if you like to check to see, so the highest sales, daily sales. So you cannot enumerate too many data points by yourself, right? So intuitively, you need an algorithm, okay? So in this algorithm, we will find the highest value in an array. So we start by assuming that element 0 holds the highest value, then use a loop to step through element 1 and the rest of array elements. So each time the loop iterates, it compares an array element to the variable holding the highest found value. If the array element is greater than the highest found value, it assigns the value of the array element to the variable holding the highest found value. It means we have a variable which is used to record the highest value until now. We scan the first two, that variable will record the highest amount of first two. Okay, we have reached to the fifth element, so that variable highest should be able to record the highest number among the first 5 elements. Okay, when we finish all the elements in the array, we should be able to do what? To have the highest value of the whole sequence, of the whole array, right? That is the idea. So this is one example, okay? So int number, we have 1, 8, 1, 12, 6, 2, okay? Let's assume we don't have any other elements, okay? Just 5 to make it easy. So we do int highest equal to number 0. It means from the start, when we only scan one element, so we only have the first element. For one element, obviously, the highest value is itself, right? Is itself. So then you can see that we do what? For int index equal to 1. We does not start from index number equal to 0. Why? Because we have processed the first element here. Okay, index number 0 has been processed when we declare the variable highest. Okay, so it has been processed. So for the for loop, we can start from the next one, which is the second element with index number 1. Okay, that's why we start from index number 1. So you see that if numbers index is higher or is greater than the highest, then we do highest equals number index. It means if the current element in the iteration is better, or it is higher, it is greater than the highest, we update the highest. Otherwise, we skip because the current one is less than the recorded highest. We do not need to update it. Okay, we do not need to update it. You can see the algorithm, this part, right, this coding part, has some logic structure. To be honest, it is more difficult than the previous materials we have learned in the previous 10 weeks. Okay, but in the future, we'll take other courses in computer programming, in data analytics, so you have to learn some algorithms. Okay, sometimes, so ultimately, you can use the package, no problem. But in the lecture, the professor will still teach you. So the intuitive statements, not detailed statements, intuitively how it works. Okay, so I'm now trying to explain to you intuitively how it works. Okay? So let me use this example as a very, very simple example to explain something a little bit. Okay. Okay, I do this. So for this algorithm, okay, so if you are still not fully 100% clear about the algorithm, so we can run it by ourselves. Okay, for example, let's assume, right? So we have numbers, right? It is what? It is, we have 5 elements. Let's make it simple. We have 5 elements, which are 8, 1, 12, 6, 2, right? We have 5 different elements. We assume we only have 5. Okay, we only have 5. So let's move on to the iterations, right? We first declare highest, right? Highest equal to the first element, which is 8. Okay, declare it. So then we move on to for loop. So for loop, let's remind you for loop how it works. First, initialize the condition equal to 1. Secondly, so check the expression if index is less than number of length. For these numbers, the length property equals 5, right? 5 elements. So index equal to 1, so 1 is obviously less than 5, so it's true. So we go inside. Okay, go inside. So the condition is, so index, right? We have iteration number 1. Okay, iteration number 1. So index equal to 1. I copied from the first iteration. Okay, I do it for her. So index is less than number of. It is 1 less than 5, right? 1 less than 5 is true. Okay. So we moved on to condition. Numbers index will be 1, right? Is greater than the highest, right? Highest. So basically, we would like to check. Number 1 is the second element, 1, right? So 1 is greater than highest. It is 8, right? It is 8. So false, right? It is false. It means we don't execute this if part. Okay, we skip. So we are done with the first iteration. We go back to this update, right? Expression index plus plus 1 plus plus give us 2. Okay. So iteration number 2. So index equal to 2, right? Index equal to 2. So I copied from here to another one, type again, okay, to make it simple. So index is less than number of length, right? It is 2 less than 5, right? It's still true, okay? So you go inside the for loop. If condition means number index, it is the third element, right? Is greater than highest. The third element, it is 12, okay? We would like to check if 12 is greater than 8. So this time, it is true, okay? Right, it's true. Because it is true, we go inside. Highest equals number index, okay? We do highest equals numbers 2, right? Basically, we have highest equal 12, okay? Equal 12. Now we are done for the second iteration. We go back to the update expression index plus plus. We have index equal to 3, right? Equal to 3, okay? Then in this case, I copy all these things. It's easy. Copy. It's easy. So index is less than number of length. It is 3 is less than 5, right? 3 is less than 5. It is true. So index number 3, it is the fourth element, right? The fourth element, it is 6, right? It is 6. So we would like to check if 6, the highest value is now 12. It has been updated to 12, okay? So we go to 12. So we would like to check if 6 is more than 12, it is false, obviously. So we skip the whole if structure. We go back to the update expression, okay? Let me do this, okay? Update expression, right? Should be before the iteration, right? Before the iteration start, okay? Okay, yeah. Okay. So now we do the next one. It is, so it is index has been updated to number 4, right? So iteration. So we would like to say index is less than number of length. 4 is less than 5, right? 4 is less than 5. It is true. So numbers 4, it is the fifth element, last element. So it is 2, right? We want to check if 2 is more than 12. So it is false, right? It is false. So then we move on to next one. We have index equal to 5, right? So the condition is index is less than number of length. So it is 5 is less than 5, right? So it is false. Okay. So after this, no iteration number 4. Sorry. This is number 4. Right? This is number 5. Okay? No iteration number 5. So here we have 4 iterations. So the highest value it is 12. After this second iteration, so no more update, right? For the highest value. Okay? You see that sometimes, right? If you cannot understand the algorithm by just reading their statements, okay, you can have a simple example here and assume you are a computer and run the algorithm by yourself, okay? So by doing this, you will have a much better understanding of the algorithm. Here, this one, you see that why this algorithm can give us the highest value in an array, right? Because when we scan to an element, if the element is higher than the recorded highest, we update the highest. Otherwise, we continue, we move on. Okay. So this is how it works. Okay, how it works. Okay, let's continue. So we have one example. Okay, assume that int array score array is defined as follows. Find the highest score in the array. Okay, we have 67, 98, 45, 23, 88. Okay, so we have the same thing, right? Highest equal to the first element, 67. So we start from index number 1, which is the second element, because the first element has been processed. So then we can use the if structure. If the score array index is more than highest, we can update highest. Otherwise, we skip, right? You can see the code is the same, right? We have analyzed, for example, if you are still confused, you can practice by what I have done here, by following what I have done here, right? Highest, first element 67. We move on to next one in the for loop, 98. 98 is more than 67, right? Update highest to be 98. For the next one, 45. 45 is less than 98, so no update, skip. Next one, 23. 23 is less than 98, so no update, right? Skip. Last one, 88. 88 is less than 98, no update. So after we scan all the 1, 2, 3, 4, 5 elements, we got the highest is 98. Okay? Okay? So if you are not fully clear about this algorithm, so you should practice what I have done. Have a very small array. Try to run the algorithms by yourself. Okay? Step by step. Then you will have understanding about how it works. Okay? So the next one is find the lowest value in an array. So we start by assuming that element 0 holds the lowest value, then use a loop to step through element 1 and the rest of the array elements. The logic is similar. So we still start to set the lowest to be number 0, index number 0, first element. Then you scan from the second element, right? If the current element is lower than the recorded lowest, update. Otherwise, no update and move on. Okay? So when the loop is finished, the lowest value has been found. Okay, like this one, we have int 81, 12, 62. So int lowest equals number 0. It means we first initialize the lowest to be the first element, 8. So for int index equal to 1, index less than numbers dot length, index plus plus, right? For this for loop, we have an if condition. If numbers index, the current scanning element, is less than lowest, we update the lowest. Otherwise, we will skip the full if structure, then move on to the next iteration. Okay, iteration. So this one is very similar as the first one. I will not try to write detail like this, okay? I will try to go through it quickly. You see? So lowest is number index number 0, it is 8. Okay, then we move on to the for loop. Index is 1. So if numbers 1, right, which is the second element, is less than lowest, 1 is less than 8. It is true, we update. Okay, lowest equal to 1. Then we move on to the next one. It is, so number index, which is 12. 12 is less than 1. That is false, right? So no update. Next one, 6. So number index number 3, which is the fourth element, 6. 6 less than 1, right? Lowest is 1, is false, so skip. So next one, the fifth element, index number 4. So the element is 2, right? 2 is less than lowest, which is 1. 2 less than 1, it is false, right? So we skip. After we scanning all the elements in the array, so we get the conclusion that the lowest value, it is 1. Okay, you can see that. So basically what I just said is this, a summary of these steps, okay? Because it's very similar, I will not try to write all the steps on the word because I feel it's redundant. So if you need more practice, right, you can try to write something on the paper by yourself. Practice how to find highest value, how to find lowest value, right? Then you should be clear about these two algorithms, okay? About these two algorithms, okay? So this is find the lowest value in an array, and we have one example, right? So we still have 67, 98, 45, 23, 88 in the algorithm. So we would like to find the lowest value. Same thing, same logic. We first initialize lowest equal to 67. Then we start from index is the second element. So we would like to check if 98 is less than 67, false. Skip. Then next iteration, 45 is less than 67, true, right? We update, lowest is 45. Then we move on to next iteration, which is 23 is less than 45. It is also true, right? So we update the lowest to be 23. So we move on to the last element, 88. 88 is less than 23. That expression is false. So no update. We skip the whole if structure. So when we finish the algorithm, so the algorithm can tell us the lowest value equals 23. Okay, 23, okay? So this is one example, okay? So in the previous section, we learned some very basic algorithms. For example, sequential scanning algorithm, right? For example, copying arrays, okay? Also, how to compare two different arrays, okay? So we learned those basic things. So in this section, section 7.6, 7.6. So this is advanced materials, okay? My feeling is that this section is the most challenging section in the whole semester, okay? So it is covered in the textbook. It is useful because I can tell you, so when you have advanced degree in data analytics, okay? So if you want to interview some positions, not very high positions, regular positions, you may not need to answer those questions, okay? But when you want to interview for good positions, okay? For example, you want to interview software engineer or data scientist in Google, for example. So they will test you those questions because those positions are very competitive, okay? Very competitive. They will ask you those algorithm questions, which are tricky, okay? And if you really, if in the future you have the opportunity to interview those positions, okay? So you will need to download a handbook from internet, which is, I remember it is like 400 interview questions, okay? 400 or 500, I don't know, I forget. So in the handbook, people summarized all the classical interview questions for computer programming or for data scientists, okay? For those questions, they are tricky, they are not easy, they are all algorithms, okay? Because for those positions, this is a requirement. And we understand this is the first course for computer programming for you. It is the first step for you to step into business analytics, okay? Data analytics. I understand that. So we try to understand the details of these several algorithms, which are still basic, but are much more difficult than what we have learned, okay? So hopefully you can get a feeling about those advanced algorithms. So in the future, you will see that all other data analytics algorithms are in a similar style. They're advanced, they're complicated, have complicated logic, okay? So you need to get used to this learning style, okay, in the future, okay, in the future. So the first algorithm is what? It is sorting. So what is sorting? It is I have number 3, 1, 4, 2. I would like to sort from the smallest to the largest. Following order, it means I feed the array to the algorithm with 3, 1, 2, 4. I need output 1, 2, 3, 4. Okay, output of 1, 2, 3, 4. So in this case, so the algorithm can scan all the array, and then the algorithm can what? Can sort the original array by following some order. Okay, following order. So the selection sort works by locating the smallest value and moving it to element 0, then finding the second smallest value and moving it to element 1. So, and then continuing the process until all the elements have been placed in their proper order. This algorithm requires the swapping of array elements. You see, that's a keyword. What is swapping? Swapping is exchange, right? Exchange. So exchange means when you call the algorithm, this algorithm will change the original array, not just read it and use it. So it has to make changes, right? So in this case, we need to use a concept we have learned before, which is ref. Okay, ref is reference. I have explained the difference between a ref versus without ref. What is that? I will explain. I think I can find it in the notes somewhere. This is my notes, right? We have used these notes before, right? So without ref, it means the computer will get a copy of the array or the variable. In this context, it's array, right? Get a copy somewhere else. Then pass a copy to the method. It means the method is using and manipulating the copy. When the method is done, the call is done, right? This copy will be deleted, and this piece of memory will be freed. Okay, will be freed. It means no matter what you have done in the method, right? Nothing will happen in the original verb because you are working with a copy. Okay, where you are working with a copy. But if we use a reference, it means we are not passing a copy. We are not even going to create a copy. Instead, we are going to pass the original variable as the argument to the method. It means, so if in the method there is any changes, any manipulation, right, to the variable, the original variable will be changed. Okay, we have explained this before. So without ref, it's a copy. Nothing will happen to the original variable. With the ref keyword, so we are going to pass the original variable, or in this case, the original array, to the method. If we swap, right, we are going to swap or exchange. So the original array will be manipulated, will be changed. Okay. Otherwise, if we don't ref, you are swapping or exchanging or revise the copy. Nothing will happen to the original variable. So for this concept, you have to be very clear, because in the future, when you work with some company for coding, this concept is used everywhere. Especially you write a lot of, for example, write some code, for write like 20,000 lines code. So this concept is used everywhere. If you are not very clear about this concept, sometimes you do not want to change the original variable. You do want to pass a copy, right? Sometimes you want the method to can change the original variable. You have to be clear about the concept. Why you want to use ref, why you do not want to use ref, okay? You have to be very clear. So you see that in this case, right, we have this algorithm requires the swapping of array elements. So we have ref. We have ref. So We have a swap method. So what is swap? Swap, it is, so we have int temp equal to a. What is that? It is, we have this temp variable is declared inside the swap method. It means it is a local variable. Why we need that? It is this. We have two bottles, okay? The first bottle have a bottle of water. The second bottle have a bottle of wine. I would like to swap this to the wine to the first bottle, water to a second bottle. How can I do that? I need a third empty bottle, right? I first put my water in the third bottle. Then I put the wine to the first bottle, right? Then I put the water in the third bottle to a second bottle, right? You need something in the middle to swap, okay? That's why we need a temp. But you see, this third bottle is only useful when we are swapping, right? But when we are done with the swapping, the third bottle can be thrown away. That's why it is local. It is not a global variable. It is a local variable. It means when we want to swap, we prepare for the third bottle, right? When we are done with the swapping, so we throw it away. That's why you can see that first temp is third bottle. A is the first bottle. We put the water in the first bottle to a third bottle first. Okay? It means the first bottle is not available. It is empty, right? We put the wine in the B, second bottle, in the first bottle, right? Now the second bottle is available, right? Finally, we put the water in the third bottle, backup bottle, to the second bottle. Then we're done with the swapping. And the third bottle, which is temporary variable, is not useful, right? So because it's local, when we're done, the variable temp will be deleted. Corresponding memory will be freed. Okay? You see, this is how it works. Okay? How it works. So this is a method to swapping two variables. Okay? Now we need what? We need to use this what? To use this method to swap, to do the swapping, Let's see. Okay. So hopefully in this today we can finish this algorithm. Okay, if as I mentioned on Monday, if we cannot finish this week, we will try to spend some time next Monday to finish this chapter. Okay, to finish this chapter. So we do sorting and searching. So we have mean index and mean value. So we have for loop. For loop is start scan less than array length minus 1. Start scan plus plus. What is that? It is, so we are going to try to make sure when we are scanning to the second element, when we finish, the second element is actually the second lowest, smallest element in the whole sequence. Okay? The intuition is that this, right? So if the array is 1, 3, 2, 4, okay? When we scan to this second element, when we're done, we will make sure that 2 has been swapped here. Okay? When we move on to a third element, we make sure 3 is swapped there. Okay? So because when we scan to the ith element, for example, fifth element, in this code, we have make sure that the fifth smallest element will be put here. In this case, right, we have the smallest element, the second smallest element, the third smallest element, the fourth smallest element, right? In this case, you see that, so the sequence is put in order, right? From small to large, okay? This order. Because for each time, so we are going to swap the second element with the remaining element, okay? It means if we are here, right? We are in the second to last element, right? So in the array. So the only possibility swap is swap 2 and 4, right? So it means we don't need to do to process number 4, because 1, 2, 3 has been put in the first 3 position. 4 is in the last automatically. No need to scan the last element. Okay, that is why you see the slide. It goes to less minus 1. Because the last element is unnecessary for us to scan. It's already the highest value, okay? So we have mean index equals star scan. We have mean value equals I array star scan. So we have this for loop. We have this for loop, okay? So when we have this, we do swap, okay? I try to go code quickly because I understand the logic here is a little bit complicated. I will try to explain the logic of the code with an example, okay? With an example, okay? So the example in the slide, okay? Let me explain it here. Let's see if we can finish something here in this today. So the array is 67, 98. I copied here. Okay, we have 67, 98. Then what? 45, 98, 45, 23, 88. 4 elements, okay? So let's assume we are going to do what? We are going to run the algorithm. Okay, run the algorithm. I will use similar strategy, okay? Like this one, okay? So when we run the algorithm, we will mimic computer performance, okay? We assume we are computer. How to run the code, okay? We can run the code by ourselves, okay? So we first declare mean int index mean value, 2 int variables without any value, right? We go to the for, we can see that we have two different for loops. The second for loop is inside the first for loop. It means for each iteration in the first for loop, there will be another multiple iterations for whole for loop for each iteration in the first for loop. Okay, that is nested iterations. Okay, nested iterations. So we will see how it works, right? Okay, we do that. So we do alter iteration number 1, right? Alter means it is this for loop. Inner means this second, it's inside the alter for loop. Alter iteration number 1. So we have, so start scan equal to 0. So length is 5, right? Length minus 1 is 4. It is true. So we do mean index equals start scan. It means mean index equals start scan is 0, right? It is 0, okay? We put it here. Start scan equal to 0, right? So mean index is also equal to 0, okay? I copied from here. Mean value is array start scan index. It is the first element, right? First element, it is 67, right? 67. So mean value equal to I array 0, right? It is 67, right? It is 67. Then we go to the inner loop, right? Inner loop. Okay, inner loop. So for inner loop, I try to use some indentation to indicate it is inside the first loop, the outer loop, okay? So for the inner loop, right? Inner loop. So inner iteration 1, okay? Inner iteration number 1. So we have what? We have if index equal to start scan plus 1, right? Start scan is 0, so index equal to 1, right? Index equal to 1. So index is less than length is 5, 1 is less than 5, it is fine. If I array index is less than mean value, right? We need to see if I array index, it is I array 1, right? Index is 1. It is what? It is 98. Second element. If it is less than mean value, which is 67, right? So it is false, right? It is false. So we have no if iteration, right? So we update index plus plus, right? Inner iteration number 2, right? We have index equal to 2, right? Index equal to 2. Index equal to 2. And we need what? We need, I copy this line, don't want to type it again, okay? So if array, now it is number 2, right? Third element, it is 45, right? 45. 45 is less than mean value. 67, it is true, right? This time, it is true, we go inside, right? We go inside, so we have, so mean value equal to what? Update to index, our index, which is 45, okay? 45, mean index equal to 2, right? 2, okay? So we're done. So then we do inner iteration. Number 3, we have, copy here to make it efficient. Number 3, it is what? It is 23, right? 23. 23 mean value has been updated to 45, okay? 23 is less than 45. Mean value is 23. Mean index is 3, right? We go inside the if. So then we, sorry, iteration number 3, I need one more thing, which is index equal to 3, right? Index equal to 3. Okay, index equal to 3. So another thing is, so iteration number 4, right? Index equal to number 4. Array index number 4 is what? It is the last element, 88, right? 88. So we have 88. Mean value has been updated to 23 in the previous inner iteration, right? So 23 is less than 88 is less than 23, false, right? So we have no update, right? We have no update, okay? We have no update. So basically, we know that. So after this iteration, right? So we see the next one, it is we update index, right? Equal to 4, right? Equal to 5, okay? Because we need to index plus plus, right? But when we compare to the iteration, 5 is not less than 5, right? So the expression is false, right? So we have no more in iterations, right? So when we finish, we can summarize mean value equals 23, right? Mean index equal to 3, okay? Then we have one more line statement, which is swap. You can see what are we going to swap? Swap is I index, I array mean index, which is number 3, the fourth element, this one, right? And ref I array star scan, which is star scan is number 0, right? We are still in the first auto iteration, right? Number 0. So we are going to swap I array number 3, I array number 0. So we are going to swap what? Swap number 3 is 23. Number 0 is 67, right? It means when we finish. So after the first outer iteration, okay, the I array will be, we have swapped 23, 6, 7. Okay, you see, this is what we get when we finish the first outer iteration. We have made sure the smallest element is put in the first element. Okay, so now we are running out of time. We are going to try to finish the whole chapter in next Monday. Okay, next Monday, and you will see that this is complicated, right? It's complicated. Okay, so that's why I mentioned it is the most challenging part, but it's a good opportunity for you to learn something, because in the future, all the advanced algorithms in data analytics in this way. If you really want to understand the code, if you want to use a package, it may be fine. Understand intuition, then use a package. But when you want to build algorithms, it is how it works. Okay, how it works. Okay.